Hello and welcome to this GCSE Chemistry explanation video about life cycle assessments. In this video, we'll take a look at why we actually carry out a life cycle assessment and all of the stages that this involves. We'll also take a look at some of the limitations of life cycle assessments and how we need to bear this in mind whilst evaluating a life cycle assessment of our own. A life cycle assessment works out the total environmental impact of a product over all of the stages of a product's life. And this is important because the population of our planet is growing every year. And as that population grows, we need raw materials, we need more energy resources, we need to use more land for buildings and farms and things like that. And not only that, we produce more waste and more pollution. And so the products that we make need to be made in a very considered way to think about the environment. And this links in with sustainable development. And that is where we meet the needs of the people today for the warmth and shelter and energy that I've already mentioned, without affecting the ability of the people who come after us to meet their own needs. A life cycle assessment looks at the total environmental impact of a product across all of the stages of its life. So what are these stages? First of all, we need to consider the raw material. The raw material in its essence might be finite, which means it is in limited supply, or it might be renewable, which is obviously more sustainable. These raw materials will require extraction from the ground, and that could be a very damaging process that destroys habitats depending on what the raw material is. And then the raw material might need processing ready to be sent off to the next stage. And the next stage is the manufacturing of the actual item itself. That might require a lot of energy resources, and this might cause a lot of pollution in the form of carbon dioxide gas and other pollutants that might be toxic, such as carbon monoxide or something called dioxins. Manufacturing products also sometimes has quite a high demand for water, for clean water that has been sterilized, and quite a lot of energy goes into that process. So if the manufacturing requires water, it is indirectly requiring energy resources. The third stage of the life cycle assessment is the use of this object. Sometimes it's really obvious when a use might have a damaging impact on the environment. So for instance, a car, which is obviously continuously releasing fumes from its exhaust, maybe carbon monoxide, carbon dioxide, oxides of nitrogen, and these cause things such as global warming and acid rain. Other products have less obvious impacts during the use stage. And then the final stage of something's life is its disposal. So once it has served its use and it can't be reused anymore, the product needs to be disposed of. And so lots of things are at play here. First of all, is this product going to be biodegradable? Could we recycle this product? Or is it going to be able to be incinerated without producing toxic chemicals? Or, if none of those things can happen, is it just going to sit somewhere taking up space in a landfill and possibly leaching chemicals out to the environment? All of these four stages need to be considered and then woven together in one overall evaluation. Not only that, there is actually a fifth consideration that isn't so much a stage, but it sort of is the connection between these stages. Because in pretty much all cases, substances that have been produced need to be transported. The material that has been extracted needs to be sent to the manufacturing plant. And even if we're going to be sending something to the recycling, some kind of lorry is going to come and collect our recycling and take it to either the recycle plant or if it's going to a landfill. And transport obviously requires some energy resource to make it work, and that energy resource is likely to be non-renewable, and that means it's going to be eating into finite resources and reducing our supplies of these finite resources, and also potentially producing carbon dioxide when the petrol or diesel is being burned inside the car. When you carry out a life cycle assessment, it might be that you are asked to analyse the environmental impact of a single product. And when you're doing this, you are explaining the things that are going to have a negative impact on the environment, and then you're explaining the impacts of this product that are more sustainable. Or, more likely, you might be asked to evaluate the choice of one product over another in terms of their impact on the environment. So this is a comparative life cycle assessment, in which case you're going to be required to make a judgment. And there is one example that is named on the GCSE Chemistry specification, which is comparing plastic bags to paper bags. And so we'll look at that in greater depth in a moment. But you can expect to be presented with information about the life cycle assessment for any product at all. So it might be using wood to make surfboards, or using some kind of polymer to make surfboards, paper cups or plastic cups, polymer window frames, metal window frames, using aluminium or wood for the frame of a greenhouse, glass milk bottles, plastic milk bottles, ceramic plates or plastic plates, or paper plates. Maybe you're asked to compare 3 things. Throughout all of this, you need to be thinking about which one has the least impact on the environment. In other words, which one is the most sustainable. A qualitative life cycle assessment is where you look at facts about the environmental impact of different products, and then you assign some value to that statement, and you come to an overall judgment based on the sum of each of these individual facts. And so if you take a look here at comparing paper bags to plastic bags, you can see we cover all aspects of the life cycle assessment here, and I've written some facts that describes these products, and therefore we can deduce what the impacts are that they will have on the environment. And so for a plastic bag, for instance, crude oil is the raw material. We know that crude oil is finite and therefore is in limited supply. We also see that the raw material requires fractional distillation and cracking, and that uses a lot of energy, but it doesn't produce very much waste. The paper bag, in contrast, is made from timber, and that's renewable, but it does require a lot of wood and pulping and processing, and this uses a lot of energy and produces a lot of unusable waste. The manufacturing processes, if we look at the statements here, they're quite similar. They need to be processed and cut. We use energy for both of them, and they're both packaged in cardboard. The use and reuse, we see here that we've got plastic bags that are considered to be strong, and so they're reusable. Paper bags only used once. Disposal, plastic bags are recyclable, but that requires energy for the collection and for the recycling process, but they aren't biodegradable, so they're just going to take up space on a landfill and not break down any smaller. Paper bags are recyclable, but this also requires energy, so no different there really to the plastic bags, but they will biodegrade, and so they will not produce pollution when that is happening. And finally, transport, we need to take the raw material from the oil rig to the plant where it gets processed, then to the manufacturer, then to the shops. And there's a similar process from the paper bag, although of course that begins at the forest. And so a qualitative life cycle assessment requires you to assess these things and decide which is overall the better for the environment. In other words, which one is more sustainable and has the least environmental impact. Now, in a GCSE chemistry question, you can usually argue both sides of the same coin here. You can decide plastic bags are worse or paper bags are worse. We just need to assign scores, as you can see that I've done here. And a smaller score means more of a negative impact on the environment, and therefore, if I was asked to consider these facts in a GCSE situation, I would be able to conclude that this is the one that I have decided is the worst for the environment overall. And it's really important that you just need to support your conclusions. It isn't that they're going to be looking for you saying one thing over another in all cases. When you're asked to do a comparison, it's about supported and linked ideas. It might be that when one person makes a qualitative life cycle assessment, they come up with a different outcome to another. And the reason for this is that whilst some things are objective facts, some things don't have a clear outcome or a clear consequence. And we call these things subjective. That means they're influenced by opinion. And so that means that different people might come to a different conclusion. And so this type of life cycle assessment is sometimes referred to as a selective life cycle assessment for a couple of reasons. Firstly, I'm having to decide which aspects of the assessment I think are most important. And secondly, during this process, I might be displaying some kind of bias for my own intentions. So an example of this is, what if a manufacturer of a paper bag wanted to advertise their product? They might use a selective life cycle assessment that only shows some of the impact of this product on the environment. For instance, they might approximate the raw material processing impact and use a value judgment to make it seem less than it is. So unless a life cycle assessment has been peer reviewed, we need to be cautious that it might have been misused to reach some kind of predetermined conclusion. We can try to make life cycle assessments more objective evaluations by including the use of numbers. And so that means being quantitative in our approach. The reason that we're able to do this is that there are some things involved in the life cycle of a product that are easy to quantify. For instance, what mass of resources are required to produce a certain quantity of this product? That can certainly be quantified in terms of the kilograms or tons of oil that might be needed to make a certain number of plastic carrier bags. Additionally, we can certainly work out the amount of energy that is used across the whole extent of the stages of a product's life, how much energy is needed to process the raw materials, manufacture the item, and then transport it on a lorry. And we can work out in joules or kilojoules the amount of energy needed to produce a carrier bag or a paper bag. We can also quantify the amount of water needed to be used per carrier bag as well, and then this allows us to do some kind of comparison. We can also work out the quantity of waste produced during the whole of a product's life, whether that is the waste produced as a result of the processing procedure or whether it is the literal waste of the object when it goes to a landfill. Each of these things can be quantified. And then once these things have been quantified, we can make direct comparisons. This product requires 10 times the volume of water to produce than the other product. This product produces 5 times more CO2 than this product. Or this product requires half as much energy to produce than this product. And all the way along, we can therefore be saying this one is having a less negative impact on the environment, and so therefore it is more sustainable. Even with all of those quantities, it is still not possible to make a life cycle assessment 100% objective. We are always going to have some limitations. And one of the biggest issues comes with allocating the impact of the pollutants that are released during a product's life. So this means that we can say how many grams or kilograms of carbon dioxide might be produced when a car drives along a road a certain distance, but we can't say for sure what the direct impact of that will be, and we certainly can't quantify that impact. And this is for a number of reasons. One of which is that ecosystems are complicated and variable, and so the impact on biodiversity, whilst we can be confident it might be negative, we can't quantify it. Additionally, the impact of a pollutant might vary depending on where it is released or when it is released during the course of a year. Additionally, we have some extra uncertainty because environmental processes are very complicated and they often interact with each other, and so a direct impact is hard to quantify. And last of all, there are certain behavioural factors as well, because people don't always follow the disposal advice from the manufacturer. And so what that means is we might have measured an impact if we dispose of it in this way, but if people choose not to do that and do something different, that will have a different effect as a result. There are a variety of different ways that an exam could test your knowledge about life cycle assessments. This could start with a very short question, for instance, asking you the purpose of a life cycle assessment, maybe asking you to name some of the stages, or complete the missing stages from a list. Or you could be asked to analyse the impact of one part of a product's life. For instance, you might be asked to state 2 potential impacts of a product on the environment at the end of its useful life. And so you'd be expected to be talking about taking up space in landfill sites, or pollution caused by burning the waste, or energy used to transport the waste to a landfill. By far the most common type of exam question is an evaluation question, where you are asked to compare the use of product X or product Y for a particular function. And when you're asked to do this, you need to make a judgment about which you consider to have the least environmental impact overall. You need to use some of the examples of the data or facts that you've been presented with in a question, and you also need to explore why those facts matter. So make your point about it uses crude oil, whereas this one uses wood, and then we need to explain that crude oil is a finite resource, which means it will eventually run out, and that makes it unsustainable. Or this product uses 10 times as much energy during the manufacturing, so that means we're going to burn a lot more coal or gas, or use a lot more energy resources, which will result in more carbon dioxide being released into the atmosphere, and therefore more of an impact on global warming or making climate change worse. Or finally, it might be that this product weighs twice as much as this product, and that will have an impact on the transportation stage, because that means it will take twice as much energy to fuel the lorry to transport it to the shop. And that will mean that twice as much petrol or diesel will be required, and so more CO2 will be released, and we're in the same situation. So whenever it's more energy or more mass or something like this, we need to link it to the ultimate problem, which is likely to be global warming. Because even using more water for one product or another will require more processing of that water to make it sterile and to take all the bits out, and that means that will require more energy, and then we're back at the more energy means more carbon dioxide produced because we're burning more fossil fuels. So in conclusion, a life cycle assessment is carried out to assess the environmental impact of a product during all stages of its life. And those stages are the extracting and processing the raw materials, manufacturing and packaging, operation during its lifetime, and then disposal at the end of its useful life, and transportation between each of those stages. And we need to be careful making value judgments, because the people making that value judgment might have a predetermined conclusion in mind. And when we're making evaluations, we need to make sure that A, we make a judgment about which is going to have the worst impact on the environment, and therefore which is more sustainable. And we need to make sure that our judgment is supported by 3 or 4 developed ideas that weave together the facts and the numbers that you've been presented with in the question. Okay, that's the end of this video. I hope it was useful. I'll see you again soon.